All right, this is a video on linear functions. This is 2.2, section 2.2 from the Math 1 book. And so we're talking about a linear function. And a linear function is something, if we remember from Unit 0, is based on the idea of a line, okay, of a straight line. So for something to be linear, okay, the change in the outputs has to be the same. Okay, so we're talking about functions, so it's about plugging something in and always getting the same output. And so basically when you look at this, I look and see, okay, these are my inputs, 0, 1, 2, 3, and 4. These are my outputs, 5, 8, 11, 14, and 17. So I look and see how I change from the first one to the second one, okay, and I add a 3. And then I look, how do I change from this one? And I add a 3. If it's linear, that's always true, okay, for the same change in x, right? So looking at that, I go, okay, so this is linear, but maybe I need a graph to kind of visualize that. So I'm going to go ahead and graph it as well. So I'm going to graph the point 0, 5, 1, 2, 3, 4, 5. I'm going to graph the point 1, 8, 1, 2, 3, 4, 5, 6, 7, and 8, 2, 11, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 3, 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And you can see if I continue this up, it'll look like that. And if I connect all the dots, you can see here that, yeah, this is going to be a linear relationship. Okay? So that stuff's not too bad. It's just looking to see, hey, is the change, right, for every one change in x, that you have the same change in y. Well, the issue here is, can I write an equation for it? Okay? So that's really what I want to be able to do, is produce some sort of a linear function. So hopefully we realize that we're going to use the idea of a 3. Okay, so it's a 3 over and over and over. Adding a 3 over and over and over is the same as multiples of 3. So our equation is made up of inputs and outputs, and we tend to use x and y. So I'm going to come up here so I can kind of work this out. And so what I'm going to say is, all right, so basically my equation is going to be, it's going to equal y, because that's my output. Okay. And then for the idea of the 3, adding the 3 over and over, that's multiplication. So that's 3 times the x. Okay, 3 times. Now the issue here is where do I start from? Okay, and so what I need to do is eventually I'm going to have to add or subtract some number back here. I'm going to just call it b, just for the sake of having something to represent it. So what I need to do is figure out what is that b. So what I can do is I can pick any point and figure it out. So for example, if I plug in a 0 for the x, the y should be a 5. If I plug in a 1 for the a 1 for the x, the y should be an 8. So I'm going to go ahead and do that. I'm going to be okay. So I'm going to pick the 1 and the 8. So I'm going to plug in an 8 for the y, and I'm going to plug in a 1 there. Okay, and I'm going to figure out what I need. So if I do this, I get 8 equals 3 plus b. I'll subtract a 3 to both sides, and I get 5. Yeah, sorry, that equals 5. So what that means is I need to put a 5 here so that this will work out. So let's test it. So the equation that I should get, we'll write it up here. The equation that I should get is y equals 3x plus 5. And I'm going to test it, okay? I'm going to plug in a 3 here, and I better get a 14, okay? So I'm going to say y equals 3 times 3. I'm plugging in a 3 for the x, plus 5. And y equals 9 plus 5, and that is 14. So it works. All right? It works. What I have to do is remember, the change is what I'm adding, okay, over and over, so I express that through multiplication. Then I got to figure out what I need to add to the end to get to the correct starting point. All right, let's do another example. So this time, I wrote the chart vertically, okay, but it's the same idea. If I plug in a 0, I should get a 12. If I plug in a 1, I should get an 8. When I plug in a 2, I should get a 4. Well, what you hopefully realize here is this changes 4. However, it changes negative 4, because this is decreasing. So the change is negative. Okay, so I'm going to plot this just so I can get a picture on it. So I'm looking at 0, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 8, 1, 2, 3, 4, 5, 6, 7, and 8. And then I'll kind of just jump down here to 4, negative 4, 1, 2, 3, 4, 1, 2, 3, and 4. And if I connect all those dots, you can see here, yes, I'm going to get a linear relationship. Okay, so it is a linear function. All right, so I got to go ahead and write the equation just like I did in the last example. So what I'm going to express as my y. Okay, the change gets multiplied by the x, and then I just got to figure out what to add to the back, and I'll use a b to represent that. So let's pick a point here. I'll plug in this first one here. So if I plug in a 0, I better get a 12. Okay, so I'm going to say I'll plug in a 12 right there, equals negative 4 times 0 plus b. And if I get 12 equals anything times 0 is 0, so the b has to be 12. So what is the actual equation or function for this? I'll go ahead and write it up here. Y equals negative 4x plus 12. Well, let's just check it one more time to be sure. So let's plug in a 4, and we better get a negative 4. Okay, so I'm going to say, okay, that's my y value. Okay, I'm plugging it in right here for this y. Equals negative 4 times 4 plus 12, right? Because that's what I figured out up here. And so I get negative 4 equals negative 16 plus 12. If I combine like terms right here, that is negative 4. And that worked. It did actually work out. Okay? So you can see here, I got to find the change, right? And it needs to be the same to make sure that it's linear. That's what gives me this straight line. Figure out what I need to add to it, okay, and then there is my equation.